Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with the problem set from lesson 518, and these are the answers. All right, let's get started. Okay, problem set number 1. Calculate the surface area of each figure below. So surface area, I'm going to start with the front, back, top, bottom, right, left, and we're going to calculate the surface area altogether. So let's do the front and the back first, and then the top and the bottom, and then the right side and the left side. So the front is a 15 by 7. So let's do these together. 15 times 7, and then times 2, because that will take care of the front and the back. And then the top and the bottom are going to be a 15 by 7, so that's 15 times 7 times 2. And then the right side and the left side will go together, and that is a 15 by 7. So 15 by 7. Oh, I goofed, didn't I? Let me back up. The top and the bottom are actually 15 by 15. 15 by 15. So 15 by 15 by 2. The right side is a 15 times 7 times 2. Okay, there we go. So let's see, 15 times 2 is 30. 30 times 7 is 210. So we've got 210 for the front and the back. And then let's do this 15 times 15 times 2. 15 times 2 is 30, so it's 15 times 30. And that's 450. That's the top and the bottom. And then another 210 for the right side and the left side. And when we add those all together, we get 870. So this is 870 inches squared, square inches. That's the area of all the surfaces for number 1. Number 2, we're going to do the same thing. Let's do the front, back together. We'll do the top and the bottom together, and then we'll do the right side and the left side together. Front and back. So the front is an 18.7 times 8.4. So 18.7 times 8.4 times 2. And then the top and the bottom, well, the top is an 18.7 by 2.3. So 18.7 times 2.3 times 2. And then the right side is a 2.3 times 8.4. So 2.3 times 8.4, and we'll multiply that by 2 to take care of the right side and the left side. So let's see, calculator for sure. 18.7 times 8.4 times 2 is 314.16. That's the front and the back. And then 18.7 times 2.3 times 2 is 86.02. That's the top and the bottom. And then 2.3 times 8.4 times 2 equals 38.64. And then when we add all those together, we're going to add 38.64 to 86.02 plus 314.16 is 438.82 centimeters squared. That is the surface area of that rectangular prism. That's number 2. Number 3, this looks like a special rectangular prism, also known as a cube. So I know all 6 sides are the same area. So I'm going to find the area of one of these sides. So I'm going to do 2 1/3 times 2 1/3, and then I'm going to multiply by 6 to cover all 6 faces. So let's see, we can change these to improper fractions. That's 2 times 3 is 6 plus 1 is 7 thirds times 7 thirds times 6, which would be a 6 over 1. I can simplify before I multiply here. So I'm going to say that 3 goes into 3 once, and 3 goes into 6 2 times. And then we can just multiply. 7 times 7 is 49. 49 times 2. 49 times 2 is 98. Over 3 times 1 times 1 is 3. So it's 98 thirds square feet is the surface area of that cube. All right, number 4. Let's see, front, back together, top, bottom together, right side, left side together. All right, so let's see, we've got front and back. The front is a 32.3 times 7.9. So 32.3 times 7.9 times 2. That'll take care of the front and the back. The top and the bottom is a 24.7 times 32.3. So 24.7 times 32.3 times 2. Okay, there's the top and the bottom. And then the right side and the left side, 24.7 times 7.9. 24.7 times 7.9 times 2 to take care of the right side and the left side. And then we got some calculator work. 32.3 times 7.9 times 2 is 510.34. There's the front and the back. 24.7 times 32.3 times 2 is a big one. That's 1,595.62. That's the top and the bottom together. Then the right side and the left side, 24.7 times 7.9 times 2 is 390.26. 390.26. And then when we add all those together, we get the total surface area. So I'm going to add 1595.62 and then the 510.34, and I get a total surface area of 2,496.22 meters squared, surface area of that rectangular prism. All right, good work. Here we go to number 5. Write a numerical expression. Well, we can do that. This is where we would say that the surface area is equal to 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. And if we fill in those dimensions, we'll have our numerical expression. So let's do that. 2 times, well, the length, we'll say that's the length. We'll say that 3 feet is the width, and we'll say that 7 is the height. So length is 12 times the width 3 plus 2 times the length is 12 times the height is 7 plus 2 times the width is 3 times the height is 7. So there is our numerical expression that will calculate surface area. All right, next. When Louis was calculating the surface area for problem 4, he identified the following. Length was 24.7, width was 32.3, and height was 7.9. However, when Rocco was calculating the surface area for the same problem, he identified the following. Length was 32.3, width was 24.7, and height was 7.9. Will they get the same answer? And the answer is yes. Look, this 24.7 matches here, and then we've got a 32.3 meters matches here, and then we have the last one, 7.9 meters, matches here. They're using the same numbers. It's just that Louis and Rocco called the length and the width different things. And it turns out that it really doesn't matter what you call them as long as you have three different dimensions. Let me go back to number 4. If I call this length and that width and this height, it's fine. I can do it that way. But imagine if I turned this up so that it was standing on its edge and kind of like a cereal box. If I did that, then I might change my mind. I might say that this is the length and this is the width and that's the height, or maybe I would call them something different. What's important to remember is that you have 3 different dimensions. One dimension is your vertical line, and we can call that whatever we want. Another dimension is your horizontal line, and we can call that whatever we want, but it's got to be different from the vertical line. And then our third dimension is that diagonal line. So as long as you have 3 different dimensions, it really doesn't matter what you call them. Height, length, width, length, height. It really doesn't matter as long as you have those 3 different dimensions. Okay, so when we go back to number 6, they used all 3 dimensions. They just did them in a different order because they called them something different. But remember, multiplication is commutative. They're going to get the same answer. All right, and then the last one, what's the most specific name for the 3-dimensional shape? Well, it is a rectangular prism, but more specifically, it's a cube because all of the edges, all of the lengths are the same. They're all 7 meters. Okay, so 2 different expressions for the surface area. Well, we could do this like we could say surface area equals 2 times the length times the width plus 2 times the length. I've got length is 7 times the height plus 2 times the width times the height. We could do it that way. Or since we know that it's a cube, we can just say the surface area is length times width, the area of one face, times 6. And we're going to get the same answer. All right. And that is it. Those are the problem set answers for Lesson 18. Hope that helps. See you next time.